Hello, everyone. I'm sorry that I have to be gone today, but the soccer team is out of town and I'm with them, so we're going to continue on regardless. If you would please have out your assignment from yesterday. It was corresponding to section 1.4 in the book. We were studying how to solve absolute value equations since chapter 1 in our algebra book is all about solving different equations. So if we need to, pause the video now until everyone has their homework out. So you can grade your own, mark any you missed, circle any ones you need to ask me about when I return, and then put your total at the top so that you know how the section went. So pause the video until everyone's ready. Otherwise, I'm going to assume that we're all good to go right now. So question number 9, answer is 9. 11, there's two answers. It's -6 and +6. 12 is a no solution. I'm guessing the absolute value was equal to a negative. 16, your two solutions are -6 and 22. 20, again, is a no solution. 21 is a no solution. 23 is just one solution. It's 20. 49 was a verbal question. So the answer was the absolute value cannot be negative, therefore there's no solution. And then 54, that statement is always. Since a minus b and b minus a are opposites, they're going to have the same absolute value. You can pick two numbers. Try 10 minus 2, which is 8, and 2 minus 10, which is -8, and both of those absolute values are 8. So those are always going to have the same absolute value. I'm going to ask us to try a warm-up question so we can review this concept in case anyone was gone, and just so you get an extra question at the bottom of your homework. So at the bottom of your homework, I would like you to try this question. Use our note packet from yesterday as a guide if you need to. It is very similar to the one that we did in the middle of the note packet from yesterday. There's two of them to use. So pause the video now, give everyone maybe 2 minutes to try this question, and unpause it after everyone's tried this question at the bottom of their homework. Even if you were gone yesterday, have out a piece of paper wherever you would normally do your homework and try this one right now. So pause the video now, please. Come back after 2 minutes. Okay, here's how this goes. I'm going to write out what this is saying in English. This is saying the statement that 2x plus 5, and we're talking absolute value. Absolute value is a distance from 0. That was a question on the quiz. I think it was our very first quiz. 2x plus 5, so apostrophe s since it's possessive, distance from 0 is 6. That means 2x plus 5 could be in one of two places because there are two places that are 6 away from 0. That means that 2x plus 5 is either at -6 or 2x plus 5 is at +6. Now you just solve your two equations, and we've solved these ones time and time again. These are two-step equations. Subtract 5 to get my numbers to the same side, and then divide by 2. And you'll get -5.5. Same over here, subtract 5, I then get 2x equals 1. Divide both sides by 2, and I get x equals a half. So 1/2 and -5.5 are your two answers. Those will be the two values that will make this statement in the absolute value either be 6 or -6, and therefore its absolute value will always equal 6. So that's how you solve problems like that. Most of them are always going to have two answers. Sometimes they can have 0 if your absolute value equal to negative, because you can't have the absolute value equaling negative. That was yesterday's. We're going to start then with today's lesson. So have your note packet out to section 1.5. We're taking 2 days to do this, but tomorrow is more of a review day, much shorter. Today's kind of the lead-in to it, the full lesson for it. So have out your note packet to 1.5 day 1. At the top it should say rewriting equations and formulas. We're going to be solving equations now with just variables in there. We call that a formula. So have your note packet out to 1.5 day 1. If you need to, go ahead and pause the video till everyone's ready. Otherwise, I'm going to move forward. So our first example that we're going to start with is one that most people are used to because they've traveled in a car. And it's the formula that we use to calculate speed. To calculate speed, we take distance and divide it by the time. So for example, if I want the speed in miles per hour, I take how far we've traveled, which is our distance in miles, and divide it how long we've been traveling for, which is our time, usually measured in hours, and I divide the two. So we're going to use that formula to calculate the distance a car goes if it travels 60 miles per hour for 1.8 hours. So this formula, this is 60, that's the speed, so I'm going to put that in for S. is equal to the distance divided by 1.8. Now how do I solve for d? I multiply both sides by 1.8. Multiply this by 1.8, multiply this side by 1.8. And when I times 60 by 1.8, I get my answer that the distance must be 108 miles. So there's the first one. Second one says, how far does the car go if it traveled for 75 miles per hour and it did so for 2 hours and 45 minutes? How am I going to put that in there? Is it 2.45? No, because 45 minutes is definitely more than half of an hour. So 45 minutes is 3/4 of an hour, because if you do 45 divided by 60, you're going to get 3/4. So 0.75. So this is 2.75 hours is how long we traveled for. How do I undo dividing by 2.75? I multiply both sides by 2.75. So take each side and multiply it by 2.75. Grab a calculator and type in 75 times 2.75, and I'll see that the distance that was traveled was 2.25, or 206.25 miles. Now you wouldn't want to do this process over and over and over again, especially if you were like keeping track of a logbook or something for a company. So instead of solving this over and over and over again, what should we do? Well, let's just solve the formula for d. So the original formula was speed is equal to distance divided by time. What did we do over and over and over again? I designated with this blue step. Well, we multiplied both sides by t. So let's just do that. Let's solve this equation by multiplying both sides by t. Then this t and that t are going to cancel out, and I will get the formula that time times speed is equal to distance. So if I want to write it with distance first, distance is equal to speed times the most normal way that you hear that. So that's the formula that I can use. Then if I'm given the speed and the time, as I just take the speed and I multiply it by the time. That's what I always end up doing anyway. So that's kind of the goal for today, is to solve and manipulate formulas when I only have variables in the equation. And that's what we call actually a literal equation. It's our only vocab word of the day. And it's an equation where the coefficients, that's the numbers in front of the variable, and the constants, which are the number terms, have been replaced by letters. So it's when I have an equation that has variables and numbers, and it becomes an equation with just variables in it. We call that then usually a formula of some sort. So for example, 2x plus 5 equals 11, if it was a literal equation, would then just be replaced by ax plus b equals c. A was equal to 2, b was equal to 5, and c was equal to 11 in a specific case, but they could be any number in more general cases. So a literal equation is like a more general equation than one that is very specific with numbers in there. So it's an equation that has just variables in it. That's what we're going to be practicing solving today, manipulating formulas. Examples of other literal equations, most of the time they're formulas. So this is the formula for perimeter. Perimeter is equal to 2 lengths plus 2 widths, because if you imagine a rectangle, it has a length, and a width, and a width, and the distance around the whole outside is 2 widths and 2 lengths. This is the formula for interest. We'll study this later when we're studying percentages with exponentials. Interest is equal to the principal amount, which is the initial amount, times your interest rate times your time. We just did this one. Distance equals rate times time. We usually call rate a speed when we're traveling. This is just a formula, 2x plus 4y equals 10, just a specific equation. And this would just be one that was given to us. A times b times c is equal to d times e times f. So all those are examples of literal equations. Note, these are the exact same steps that we've used before. It's still simplify, same side, solve. The only difference is that when we're doing same side, we're looking at the variable term we're solving for and our non-variable term. So we'll be looking at, if we're trying to solve for x, we'll be looking at x terms and then not x terms. And then the last step is always solve for your variable of interest. So example, we're going to take the one that was our example literal equation. So if I had the equation 2x plus 5 equals 11, let's solve that first. So a good strategy when trying to solve literal equations or formulas is to imagine that everything besides the variable that you're solving for is a number. Put a number in for all of those, and then just go through the steps that you naturally would. So if I was trying to solve ax plus b equals c, I might pick a number for a, pick a number for b, pick a number for c, put it in there, solve that one, and then use that as like a guide or a template. So I'm going to use this as my guide. So subtract 5 would be my first step, because really I have x terms variable terms and not x terms, number terms. So subtract 5. I then get these canceling. Well, I get the 5 and negative 5 canceling, and then 11 minus 5 makes 6. So I get 2x equals 6. Now I have my x terms and my not x terms. Last step is to divide by 2, and I get x equals 3. Now let's use those same steps we just did here over here. What was the first thing I did? I had my x terms and I have my not x terms, my other variable terms. My first step is to get my not x terms to the same side, because there is no simplify step here. There's no distribution. There's no like terms on the same side. So how did I do this? I subtracted b. In this case, b was a 5, so I subtracted 5. I then have ax equals, well, if I know it's c and b, where I could simplify this, but I don't, so I have to just write c minus b. Now I'm here. Now what did I do? Well, I divided by whatever number was out front. In this case, it's an a, so I'm going to divide both sides by a. And what I'm left with is x is equal to c minus b divided by a. You might also see the book write this as x equals, instead of dividing both things by a, I could divide them individually by a. And that would be the same thing. So you could write this either way. But the first way is completely fine. So that would be how we solve the literal equation, but I use the specific case with numbers as my guide. I'm going to ask you to try one just like that. So pull out your whiteboard, maybe draw a line down the middle, solve the one on the left first, then use it as your guide to figure out how you would solve the one on the right. Let's take maybe 2 minutes to try this. When you get your answer, compare your answer with a neighbor, see that you got the same x value for the left one, then see if they got the same answer for their literal equation on the right. So pause the video now, unpause it once everyone's had a chance to try. Okay, let's go. Here's how this one would work. This would be a not x term, a not x term, and an x term. Is there any simplifying to be done? No, there's not. So my next step is to get same side. This is a positive 3. So how do I undo a positive 3? I subtract 3. I then am going to have 16 equals, this is still a negative 2x. Let's go over here and actually do the same step. This is a not x term, not x term, x term. I need to get my not x terms to the same side, so I'm going to subtract b. I then have c minus b equals negative ax. Last step is to divide by a negative 2 here. If I actually know the numbers, I can divide it. I'm left with negative 8. Over here, same step. I have negative a times x. How do I undo multiplying by negative a? I divide both sides by negative a. So my final answer is c minus b divided by negative a equals x. And I'm done. There's the answer to my literal equation. If I actually knew the values, and I could substitute in for c, b, and a. In this case, I would put 19 in for c, I would put 3 in for b, and I'd put 2 in for a. I would have my answer. So there you go. Hopefully you got the same thing. You can put the whiteboards back, because we're going to continue on in the note packet with the second example. So we're going to solve this literal equation for x, and then we're going to use that one to solve the specific equation. So let's still, I think it's a good idea to use a guide. So if I were going to be using a guide here, I'm trying to do ax equals bx plus c. Pick some numbers for a, b, and c. And I try to pick some numbers that aren't 1 and 0. Pick numbers besides that. So maybe something like 7x equals 2x plus 3, or something like that. Okay? Well, if I were solving this one, I would have x terms, and not x terms. I need to get my x terms to the same side. So how am I going to do that? Well, I would subtract 2x from each side, because I already have my not x's on the right. These would go away, and I would be left with then 7 minus 2x. I'm going to write that. I really have 7x minus 2x equals 3. We're going to simplify this to obviously be 5x here in a second, but I'm going to write this because it's going to help me over here. Because I'm going to do the same thing. I have x terms, not x terms. I need to get my x's to the same side. So I'm going to write it like this. I then have ax minus bx equals, these are going to cancel, c. Same thing. So if you were doing it here, my first step would be to subtract the bx. I then would be here. Now, how do I do this? Well, really, in my head, what I'm doing is I'm doing 7 minus 2, and then I know I'm counting x's with it. 7 minus 2 makes 5. So I would write 7 minus 2 in parentheses, and that's 5. I have 5 x's. Well, here I don't know what a and b are, so I have to just write a minus b. If I knew whatever that was, I could find it, and then I'm going to put an x to the right to know that I'm counting x's, equals c. This equals 3. Now I have the exact same thing, so that's my next step, is I would do a minus b, whatever those numbers would be, and then I'm going to put an x to it to know that I'm counting x's, equals c. Now my last step here is to divide both sides by what x is getting multiplied by, so I would end up getting 3 divided by 5. Same thing here. A minus b is multiplying x. How do I undo multiplying by a minus b? I divide both sides by a minus b, and I'm left with x equals c divided by a minus b. I'm just putting parentheses around it just to show that those two items were grouped together. So my last step here is going to be divide both sides by a minus b. Same thing I just had when I was using my guide. And there's my answer. I've solved for x. I'm now going to use this to solve a specific scenario. I'm going to solve this when a equals 11, b equals 6, and c equals 20. So I'm going to plug that in. So I would have x equals c is 20 divided by a minus b is 11 minus 6. That would be 20 divided by 5, and that equals 4. I can solve that quickly once I have my formula. Now check this out. If I didn't have my formula, I'd have to have gone back and I would substitute a. I would put 11, so I'd have 11x equals 6x after I put 6 in for b plus 20. If I solve this, I would subtract 6x from both sides. I would get then 5x equals 20. Then to solve, I divide both sides by 5, and I get x equals 4. I get the same answer. The benefit of the formula is it's less work. So the benefits of formulas is they're more work one time, but once you've solved them once, they're much more efficient if you were going to be doing the same process over and over and over again. One more example that I'm going to have you try, and this is one that we're going to use a lot in the next chapter in the next chapters when we start graphing lines, is we're going to be solving equations for y, because the end goal is to get equations in the form y equals mx plus b, because if you've seen anything like that equation before, you know that that's what's used to graph lines. M turns out to be what's called the slope, and B turns out to be the y-intercept of the graph. You don't need to know too much about that now, just know that that's where we're going when we do something like this. So our goal is to solve the following equation for y. That means make it so that y is a function of x. When someone says y is a function of x, they just mean solve for y. Make it look like y equals, which means that if I gave it an x, it could tell me what y is. So y depends on x. So here I've got the equation 3x plus 2y equals 8. And I'm trying to solve for y. So I have not y term, a y term, and a not y term. I need to get my not y terms to the same side because there's no simplifying to be done. So I subtract 3x. I'm then left with 2y equals 8 minus 3x. And then my last step is to divide everything by 2. Divide by 2, divide by 2, divide by 2. I'm left with y equals 8 divided by 2 is 4. I can't divide 3 by 2. You could use 1.5, but instead I'm just going to write it as 3 over 2, 3 halves, x. And there's my equation. In later chapters, we'll talk about, like I said, that this turns out to be the y-intercept, and this turns out to be the slope. You would see some books would write the answer the other way around. They would write negative 3 halves, x plus 4. And those are the same thing, because the order in which you do addition doesn't matter. You can do 5 plus 7, 7 plus 5. They mean the same thing. So there's a couple questions that ask you to solve for y, but they'll use the phrase, make it so that y is a function of x. Now if I gave it an x value, I could compute, and you could tell me what y is. It's very helpful for making a table. I'm going to ask you to try one like that just for practice so that I know you can do it and be successful in the section. So your equation is negative 2x plus 3y equals 6, and write it so that y is a function of x. That means get y by itself. Make it look like y equals something. So pause the video now, give everyone maybe a minute and a half to try it, and unpause it once everyone's had a chance to try. Okay, let's see how we did. This is a not y term, a y term, and a not y term. You need to get your not y terms to the same side. So how do I undo minus 2x? Well, I obviously add 2x. So I add 2x to each side. I'm then left with 3y equals 6 plus 2x. And my last step is to divide by 3. I divide everything by 3. I'm then left with y equals 2. I can't simplify 2/3, so I just write it as 2/3 x. And there's your answer. You could have also written this as y equals 2/3 x plus 2. Some people might have even just left this when they divided this by 3. They might have just divided the whole side by 3, and they would have written it as 6 plus 2x, all divided by 3. But most of the time when we do that, we're going to divide each term by 3, and we would have written it like the top one. So I would say get it into one of these two right here forms when you're writing it. And that's it. I hope you had a good day. And then the practice homework problems for this section are 1.5 day 1, which I believe I will be right here. So if you want to, you could leave the video paused and on this view so that you could check your answers as you work. As you see, most of the ones you're going to be doing at the start are the ones where you need to solve for y, because that's probably the most important skill coming out of this section. So have a good day, and I'll see you when I get back.